Let's finish with our parent functions. The first parent function we're going to look at is the parent linear function. You know a lot about linear functions. So the parent linear function is the function y equals x. It is the line that has a slope of 1, positive slope of 1, right? Because this is positive 1 times x. And it goes through the point of origin. That's the only point, the only x-intercept and the only y-intercept is that point of origin. And we know that depending on whatever changes we might want to make to this, we can make it a more steep slope, or we could make it a more shallow slope, or we could put a negative in front of the x and we could make it a negative slope. So the parent linear function is where all other linear functions come from. The domain of our parent linear function is all real numbers. The range is all real numbers. For us, the x-intercept is the origin, and the y-intercept is also the origin. This function is increasing when the slope is positive and decreasing when the slope is negative. And this function has no symmetry. It's not symmetric about the x-axis. It's not symmetric about the y-axis. So there is our parent linear function. Here is the parent quadratic function, the dark function here. It is f of x, or y, equals x squared. Now we can put a coefficient in front of it that would make changes to it, but here is what I want on your paper. It is f of x equals x squared, or y equals x squared is the parent quadratic function. So the domain of any quadratic function is all real numbers. We're not going to get into any trouble putting any real number into that function. The range for the parent function is 0 to positive infinity. Now, yes, we could put a could be a negative value, and that would reflect it over the x-axis, but for us, it's just this interval, and it does include 0. That's why that's a bracket. The x and y intercepts are the point of origin. This function is decreasing, and again, we're just worried about the parent function. This function is decreasing from negative infinity to 0 and increasing from 0 to positive infinity. This is an even function. Remember, an even function is symmetric about the y-axis, so that's an even function. It has y-axis symmetry. We have a relative minimum at the vertex point. So wherever the vertex point is, we have a relative minimum. For us, that minimum happens at the point 0, 0. So there's the information I want you to know about the parent quadratic function. Here's the parent cubic function. And it doesn't have all that silly a mess with it, so thank goodness. So the parent cubic function is f of x equals x cubed, or y equals x cubed. It is a function that has a domain of all real numbers and a range of all real numbers. There is only one x and y intercept, that is the point of origin. This function is always increasing. It is an odd function, and it has point of origin symmetry. So it is an odd function, and it has point of origin symmetry. If I take any point on this function and reflect it directly over the point of origin, it will map to another point directly across it. So that's what it means for it to have origin symmetry. Now, again, we can stretch this by putting a value bigger than 1, and that just means our outputs are going to grow by a factor of 3, right? Or we could compress it or shrink it and have our outputs not grow as fast, and that means it's just going to look like so. So we can make some transformations on this parent function, but I want you to know everything there is to know about these parent functions so that when we talk about doing transformations, you'll be able to start with a parent function and then make those changes. Another parent function that I want us to talk about is the square root function. The square root function, y equals the square root of x, has a domain of positive numbers and 0, or all non-negative numbers. So the domain is 0 to positive infinity because this keeps going. The range is the same. So looking along the y-axis, it's 0 to positive infinity. There's only one x and y intercept, that is the point of origin, and this function is increasing everywhere on its domain. This function has no symmetry. This is not an even or odd function. This is all the information that we can glean from the parent square root function. We could make transformations on it based on what we know about the graph and the behavior of this parent function. Another parent function that we need to know how it behaves and all the little information about it down here is the absolute value function. The absolute value function is technically a piecewise defined function, and we'll talk about piecewise defined functions later on, but what you see here is y equals the absolute value of x, and its behavior is linear based on different pieces of its domain. So on the pieces of its domain that are 0 and greater, it behaves like the parent linear function, just y equals x. For all negative input values on this function, it behaves like y equals negative x. The domain of this function is negative infinity to positive infinity. The graph goes on. There's no values, real number values that I can put into this function machine that are going to give me trouble. The range, as we can see from the graph, is 0 to positive infinity. On the parent function, there's only one intercept. That's the point of origin. This function is decreasing for all negative input values of x and increasing for all positive values of x on this end of the number line. This is an even function. It is symmetric about the y-axis, and that's what an even function means. It has y-axis symmetry. So there's the parent absolute value function. And finally, let's talk about the parent reciprocal function. This is the parent reciprocal function, and that is the function y equals 1 over x. So it has two pieces. It has this behavior in quadrant 1 and this behavior in quadrant 3. So the domain of this function is all real numbers except 0. This function travels very, very, very near the y-axis. As x gets closer to 0, the outputs on this function get really, 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 really big. And as x gets really, really, really big, tending toward positive infinity, the outputs of this function tend toward 0. So it never actually touches or crosses either axis. It has vertical and horizontal asymptotes, but the domain of this function is all real numbers except for 0, because we never can get to positive or negative infinity. And the range is the same. If we look along the y-axis, all of those output values going to positive infinity and all of those output values going to negative infinity, but not including 0. So there are no x and y intercepts. This function is decreasing for all negative input values and and still decreasing for all positive input values. So this function decreases on its entire domain. This set and this set are the same. This function is always decreasing on its entire domain. It is an odd function because it has point of origin symmetry. Pick any point and reflect it over that point of origin, and it will map you to another point on another part of the graph in another quadrant. So it has point of origin symmetry, which is the definition of an odd function. It does have a vertical asymptote, that is the y-axis, and it does have a horizontal asymptote, which is the x-axis. So that's all, just an introduction to all the parent functions. Make sure you know their domains and ranges, because from here we're going to talk about performing transformations on those parent functions. So that's it. Come to class next time and we'll work on homework.